In this video, we will take Amazon's daily sales data for past 2+ years from 3 different regions like North America, Europe and Asia Pacific, having 3 different file formats CSV, JSON and Parquet, load them into internal stages under different partition using Snowpark File API, curate the raw data and then design fact and dimension tables and populate large history dataset as well as delta data and build entire end-to-end data loading and data transformation code using Snowpark Python library. At very high level, most of the online businesses having global presence follow this approach when it comes to data engineering and data analytics workload. And if you understand this end-to-end Snowpark Python hands-on guide, you will not only learn how to code using Snowpark, but you will also learn how to process and crunch large volume of data sets and build fact and dimension structure in your data warehouse platform. Once we complete the data processing activities using Snowpark Python library, we will quickly draw basic dashboard using Snowflake Snowsight platform, including filters and validate the data. Most of the Snowpark Python examples are very focused and narrow. If you really want to learn how to use Snowpark and leverage its different APIs for data engineering activities, stay tuned until the end of this video. And yes, if you really want to participate with me and try everything by yourself, you need to be ready with following things. Snowflake free trial edition, so it will not cost you anything. Next, you need Python 3.8.x. Snowflake Snowpark connector library does not work at higher version of Python. Snowflake Snowpark Python library installation, VS Code or any other editor that you are comfortable with. If you want to load the data using SnowSQL CLI, then probably you need SnowSQL in your local machine. So before we proceed, let's understand where can you find the code. Welcome back to my channel Data Engineering Simplified, and to this Snowpark Python end-to-end guide for data engineering workload for true data professionals and data engineers like you. We will not talk about Snowpark's machine learning capabilities in this guide. We are going to have a separate playlist for machine learning workload. Follow these instructions for better visual experience and to learn faster while watching this video. The sample dataset, including the folder structure, can be downloaded from my Git account. There are 3 datasets available from 3 different countries, US, France and India. There are 3 types of file formats, CSV, JSON and Parquet. Each source is further partitioned by date. You can download the bulk sales order dataset for your practice from the root location of my Git account. Since we are using 3 different countries' data to generate a sales revenue, we are going to use another dataset called Forex dataset. And this dataset is going to capture exchange rate between US dollar and the local currency. While practicing, you also need to create a Snowflake object. So all the Snowflake SQL script and Snowpark Python code is also available in my blog page. So while watching the video, you can go and copy paste the SQL instruction and create your Snowflake object. The link for my Git location as well as for my blog page is given in the description section below. If you have any specific queries or a doubt, feel free to drop a note through the comment section, or alternatively, you can drop me a message in my Instagram account. Before we jump to the Snowpark Python coding, let's talk about end-to-end data flow in more conceptual way. You might be very familiar with the data flow. However, to make sure that we all are in the same page, it is important to understand how the data is flowing from source layer to the consumption layer. In any complex and a large enterprise data engineering project, you don't just load CSV data or a flat files. You also have different kind of file formats like JSON data file or a Parquet data file, and you combine them before you make them usable and consumable for your analytics team. They need to be staged either in external stages like AWS S3 or Azure Blob or Snowflake internal stages to store large dataset from multiple sources having multiple file format. We design the partition-based folder structure. From there, they need to be loaded to the landing zone or so-called source zone without any transformation. So, this source layer is primarily mirroring the data from your source systems. This layer is more for data profiling to understand what can be kept and what can be moved further to the curated layer and forward. Next step is to move the data to curated zone where some basic transformation is applied to bring data into a uniform shape because the data is coming from a different sources. You may apply some filter criteria or a deduplication, and once it is curated, then we build a model data layer, and it is generally called dimensional modeling, and it happens in the consumption zone or a consumption layer. So the analytics team can consume the efficiently modeled, clean, and most trusted data. So this is how the overall data flow looks like at very high level. If you are working in a more complex environment, you may have more layers. However, these are the broad zones or schemas what we have seen in any data engineering project. Let's simplify the data flow diagram and put it in a more logical form, just keeping the CSV data file in the center of our discussion. We all know that the data warehouse follow layered approach to keep different type of data. When I say different type, I mean raw to curated to modeled, and each layer is represented as a schema. Some data project may create databases for each layer, but in this tutorial, we will use source schema. We can also name it a raw or a landing schema. Then the next schema will be curated schema followed by consumption schema. Some companies or a data project name these layers as a bronze, silver, gold, or L0, L1, L2, L3, and L4. We all know Snowflake cannot directly extract or pull data from data sources, be it RDBMS or FTP or API sources. So in this tutorial, we are assuming some external process will pull and keep the data in our local machine. However, in a real world data project, it could be some kind of tools like Fivetran or a Click Replica or a Stitch or a Matillion kind of SaaS platform that will be responsible for data extraction. We will load large amount of data and we will organize the data under different date partition and will learn how to process partition data. Using Snowpark's File API, we will load the data into Snowflake's internal stage. We are primarily using internal stage, so while watching this video, you can practice and try yourself without any external dependency. Again, in customer project, these internal stages might be replaced with external stage mapped to S3 or Azure Blob or Google Storage or all of them. After data is ingested into Snowflake's internal stage, we will use Snowpark's data frame API to perform deduplication and harmonize the data and apply some basic curation logic. Once data is curated, we will build dimensional modeling structure at consumption layer, and for that we will again use Snowpark's data frame API. We will also create transactional fact and periodic snapshot fact table and see how Snowpark help us to write Python program. If we consider all three regions sales data, then the data flow would look like this. The US sales data is available in Parquet format, the India sales data available in CSV format, and the France sales data is available in JSON format. They all will be loaded into Snowflake internal stage under different region, file format, and date partition. We will move the data from our local machine to Snowflake internal stage using Snowpark File API. After raw data is loaded to the internal stage, Snowpark will curate the data and insert the curated data set to the curated schema for each type of data source. And finally, Snowpark Python code will load dimensional data, transactional fact table data, and periodic fact table data. And we will build a quick dashboard using Snowsight dashboard capabilities. We are also going to use two more schemas that will help us to hold some of the common objects like file format or audit tables to capture delta loads on a regular basis to improve our monitoring approach. So you can pause and understand this entire data flow, the data architecture diagram. Before we profile our data, let's understand what product segment we are going to work in this tutorial. We all know Amazon sells thousands of products, and to have a meaningful business case that can also be practiced from our local machine, we just need to focus on a specific segment. And for this tutorial, I am going to focus on Amazon sales data that are related to mobile handset across 3 different regions. And this is how the CSV file and the JSON file looks like. So this is one of the sample CSV file which falls under source equals to India, format equals to CSV, date equals to the date field followed by the order.csv. Here I have order ID, customer name, mobile model, which is the combination of brand, model, color and the memory. Quantity, price per unit in local currency, total price, if any promotion code applied during the sale, order amount, and this is the tax amount, order date, payment status, whether it is pending or paid, shipping status, whether it is in transit, returned or delivered, and what kind of payment method is applied, payment provider, what is the mobile number and what is the delivery address. Moving to the JSON format. So JSON is a multi-line JSON and it captures exactly the same detail what we have seen in our CSV file. Since Parquet is a non-human readable content, I won't be able to show the Parquet data in the text format. So let's start. The first step is to create a Snowflake user and a virtual warehouse, and they will be used throughout this course. Once the user and a virtual warehouse is created, we will quickly check the Snowflake account connectivity using Snowpark Python API and print handful of record to validate whether it is working or not. So I am in my blog page and here are the script for creating a virtual warehouse as well as a Snowflake user. Let me copy this statement. I'm going to remove this statement because this is a folder and I can change the role directly from this menu. So I am going to create a virtual warehouse called Snowpark ETL virtual warehouse of a medium size. It is done. Next, I am going to create a user called Snowpark_user. And before I create, I have to change my role to the account admin role. So Snowpark user is created. Now let's assign a system admin role to this Snowpark user. The last statement is not required, but I just executed it. So this is my Snowpark program, which is going to establish a connection with Snowflake, and it will check what is the current role, current database, and it will also execute a statement to the sample database called customer and see whether the data is being printed correctly or not. Let me copy this. Make sure that you change the account name as per your Snowflake account name. So this is a pretty simple code. It is actually calling this get Snowpark session, running the context function like current role, current database, current schema, and current warehouse. And it is running a select statement on the Snowflake sample data customer table and printing those values. So if my user is created correctly, warehouse is all good, role is assigned to the user, I should be able to fetch the record. Let me run this. So my file name is 00connectivity.py. And I can see this is my current role is system admin and it is connected to current database is a sample database. The schema is tpch_sf1 and my warehouse is Snowpark ETL warehouse and it has used the warehouse to print the data. So my overall connectivity is working fine and I'm able to see this info based on my logging configuration. So we completed our first step successfully. Let's move to the next step. Step 2. In this step, we are going to create database and schemas so we can host tables, sequences, object, file format, and views. We will start with one database called sales DWH and 5 schema objects named source, curated, consumption, common, and audit. So this is how my SQL script looks like. I'm going to copy them. When you are creating the database and schema object, make sure that you have the same role through which you have created the user and virtual warehouse. Else you will end up in a privilege issues. Okay. So my database and different schemas are created successfully. Okay. And this is how it looks like. So we have a source database, we have a curated database, consumption database, audit, and common. Moving to the next step, step 3, we are going to create internal stage object inside our source schema. We all know internal stage is very similar to the external stage. However, we don't have any external dependency when we create internal stage. Once our internal stage is created, we are going to review our CSV, JSON, and Parquet order files from 3 different regions. And we are going to understand how these files are going to be processed for the curation and consumption layer. So this is the instruction through which you can really create an internal stage. Let me copy it. So let me select the source schema. Let me run this create stage statement. So my stage is created. And these are the property for the stage location. Let's run the list command and see whether we have any dataset available or not. So I do not have any dataset available in my internal stage. Now let's understand how the order files are partitioned for different locations like India, US, and France, and how they are further partitioned by file type, followed by date, and followed by actual file. So if I go to source equals to IN, see it is format equals to CSV. If I go to source equals to FR, it is format equals to JSON. And if I go source equals to US, the format equals to Parquet. You can follow a different partition mechanism for your project. However, this is a very standard way to represent your partition folder. So the new team member joining your project can automatically understand this source belongs to US, India, or France, and this source is having this file format, and then all the files are further partitioned by order date. If there is a one or a multiple order file, that order file belongs to this particular date, and accordingly it will help them to validate during the transformation process. So if I go to the CSV, this is how the CSV looks like. If I am processing multiple order files in a single day, it is possible that I have multiple order files under a single partition. However, for simplicity, in this example, we have kept only one order file per order partition folder. Now let's analyze how the order data looks like. Even though there are different file format, each of the file format will have almost a similar structure like this CSV file. So order ID is a unique alphanumeric character. Then we have a customer name. Then we have a mobile model. Then each order will also specify whether you have purchased 1 or 2 or 3 quantities and what is the price per unit. Then the total price, which is a multiplication of these two elements. Then we have a promotion code, because generally when we purchase, we also apply a promotion code. And after that, we have a total order amount. Each of the promotion code has a percentage discount. So after the discount, you will get the order amount. On the order amount, you have a tax as a percentage value. So after applying this tax, you will get this tax amount. And this is the order date. And if your order status is pending or it is fully paid, you will see from the payment status. Then whether the shipping is returned or transit or completed, that you will find it from this column. Then the payment method and the payment provider. Then this is a mobile number, which is kind of a unique for each customer and their delivery address or a shipping address. If I look into the France data, here also it has a alphanumeric order ID. Instead of a mobile number, this field says phone number and this is a delivery address. And here you see this is the date. So same CSV data is represented here in a JSON format. And since we cannot display the Parquet file, I am just ignoring the Parquet file for now. In the next step, we are going to load this Parquet, CSV and JSON file into our internal stage using Snowpark File API. Alternatively, you can use put command through your SnowSQL CLI and load the data under different partition. Step 4. We are going to load all the order files, be it CSV, JSON and Parquet, to the internal stage location using Snowpark File API. Let's quickly review our Snowpark Python program. Get Snowpark session is a method where I am actually getting the session object. So this is a method which will recursively go inside my partition folder and pick all the file name and create a list of file names. Then this is the main method which actually get the CSV file name, Parquet file name and JSON file name, and finally run the file.put command through Snowpark session. So first it will load the CSV data, then it will load the Parquet data, then it will load the JSON data. Okay, and once it is completed, we would be able to see all the item in our internal stage. Let me go back to my VS Code. So this is my directory path and I am calling this traverse directory, which is this particular small function which will traverse through the directory, and it will give me the name of my CSV file, Parquet file and JSON file. And this is the stage location where I am going to place all the CSV, JSON and Parquet file. Now the question you may have it in your mind, why do I need to iterate? Why can't I run a single put command and upload all the files? Yes, you can certainly do that. The challenge with that, you would not be able to create a partition context in your stage environment. So what I suggest, you can simply open your SnowSQL CLI and try to follow the star.json or star.csv or star.parquet and give the location of your stage environment and see whether you would be able to create a partitions folder in the stage environment or not, and leave your comment in the comment box. So let me run this program. This may take a while, so I am going to fast forward and show you once my file is loaded into my environment. I can see total I have 3722 files available in my stage location. Let's see how many files belongs to France, India and US respectively. So I have 1241 file belongs to country France and the file format is JSON. And when I go to CSV file which belongs to India, I have again almost 1241. Let's go to US. And here also I have 1240 files. So now I got roughly 2+ years of order data available in my stage location. And this I got it using Snowpark's File API. Now many people will have a question, I can also do the same thing using a put command. However, if you look into all these three sections where I'm processing the CSV file, followed by Parquet file, followed by JSON file, the code looks exactly same. So I can really write a single method, pass a parameter and reduce the number of lines to achieve the same goal, which we will do it in our future chapters. But now just to bring a clarity how we can write the Snowpark File API program, these three logic in a separate blocks. There is one more important thing which I would like to show you is about duplicate data. In real life scenario, when we are placing a file into our stage location, it may happen that the same file is processed twice and the file name is renamed based on the timestamp. And if you look into this particular instance, here I have the same file which is processed twice and this file is available in my stage location. During the curation process, we will make sure that we will deduplicate these values and duplicate items are removed based on time logic. I am assuming you have been with me so far, and if you really want to practice and load this dataset along with me, you can go to my Git account and you can download the sample dataset available in zipped format. So the next step in this flow is to create file formats in our common schema layer. So to validate whether we have loaded the correct order data, whether be it JSON file, Parquet file or CSV file, we have to create the file format, associate the file format with our internal stage and query them. That way we can quickly profile the dataset and understand what rules to be applied. So these are the SQL script which will help me to create the file format object. and we are going to create all the file format objects in the common schema because these file formats are common across all other schemas. So if you see, this is my CSV file format, next my JSON format, and third is a Parquet format. Let me copy it. So I have selected this and let me execute it. So I got the file format created. Let me quickly validate that. My file formats for CSV, JSON and Parquet created. Let me describe one of them. And this is how it looks like. Good. Now my file format is created. What can I do with that? I can really use the dollar notation and treat my internal stage location as a table by associating a file format. Let me copy this statement and run it. So I'm going to change my schema because all the data is available in my source location. So if you look, I am using T, which is nothing but an alias here, and this is my file format which is available in the common schema. And let me run this statement. So I can see I have a 1.4 million records available where my order date start from January 2020, and this is how the data looks like. Since I have a lot of data, the computing starts taking time. Okay. This is the query I can use to see the Parquet data, and I am also using a dollar notation. However, in Parquet or a JSON, my column is always $1. And if you have not seen my external table tutorial where it has been explained in detail, I would request you to go and watch that. So if you look into this, this is my Parquet file stage location, and let me do it. Let's run this statement. So here I have 862K record, close to a million, but less than that. And here also the order date start from almost 4th of January onwards. Okay. If you have to run a select statement on the internal stage which has JSON data file, then this is how the query looks like. Again, like Parquet, JSON also has a $1 notation. It does not have any other extra column other than $1. So you can write $1 followed by name of your element, and it is a case sensitive, and then you can attach a file format and run the query. I have a complete playlist which talks everything about JSON. If you are not very familiar how to process a JSON, I would request you to watch my JSON playlist. Let me copy this query to my Snowsight. Let's run this query. This is the sales order data from France, and you see all the customer from France, your mobile key, quantity, unit price, and remember this unit price and the total price are in their local currency, not in the USD. And this is the tax amount, and if you look into column name, the tax column is called GST. For France and US, this is called tax. And here it is called phone. For India it is called mobile, and for US also it is called contact number. So when we are moving the data from our source layer to the curated layer, we are going to bring the uniformity in terms of a column name. So this is how you can run the select statement on the top of your internal stage, whether it has CSV file, Parquet file, JSON file, ORC, Avro or XML. In the next step, we are going to load the data from the internal stage to the source tables using Snowpark Data Frame API. Query. So this is a select query which will allow us to execute on our internal stage without storing the data into the table. Let's recap what all things we have done. So we have reviewed all those files. We managed to load this Parquet, CSV and JSON data file which are available in our local machine under different partition folder into internal stage, and this stage belongs to source schema. We have created file formats so we can parse CSV, JSON and Parquet data, and we have executed queries where we can see and validate the data quality. The order data looks perfectly fine. So the next step, before we move the data into the curated or a clean layer, we need to create tables in the source layer, and we are moving the data from internal stages to the source tables which are residing into the source schema. And for that, we are going to use Snowpark Data Frame API. We really apply any transformation, we would like to load the Forex data. Since we are getting data from a multiple region, if we generate a total revenue report, it would be little hard to understand. For that, we have to bring a uniformity in terms of a currency. And we need to have a Forex data available before we convert all the local currency into USD. Since Forex data is a very small data set, we are not going to use Snowpark for that. And I will quickly show you how you can use Snowsight to load a small data set. Where you can refer this foreign exchange rate data section, where I am creating a table under the common schema. The name of the table is exchange rate. The exchange rate data file is already available in my Git location, and this is how it looks like. Since I have already loaded the data, this is how the exchange rate data looks like. So I have data available since 2019 until today. Now let me show you quickly how can you load that CSV file if your table structure is available in Snowflake. When you click on the table, you can click on this button called load data, and it will allow you to load the data, and you have to select a file format. And once the correct file format is associated with this operation, your data will be automatically loaded into Snowflake. Okay, since I have already loaded the data, I'm going to skip this simple trivial step and leave it up to you to go and try that out. Step number 7. Now in this step number 7, we are going to move data from our internal stage to our source table. The primary reason to do that, querying the internal stage takes much more longer time than querying a table. And this is how the process looks like. We have CSV data, JSON data, and a Parquet data, and they are available in a partition format. From that partition, we are going to run a copy command through our Snowpark API and make sure that we move the data Snowflake internal stage to internal table. And we will also try to cast data type. So by doing that, we will make sure that invalid data is filtered out and only the valid data is coming inside our Snowflake tables. So you can find the code to move the data from stage to source schema in my blog page. And so there are 3 different methods which I have written to ensure that we have enough clarity and we can also change what we want for our individual file type. So the first method, ingest India cells, is running a copy statement, and I would tell you the reason why I am running a copy statement other than running copy to table API. These are the 3 metadata elements which I want to insert in my source table, and current copy to table API does not support these methods, and that's why I am being forced to run the copy command in using the SQL statement. Okay, so we have already seen our select statement. The same select statement is being wrapped in my copy command, and it is actually inserting data into my sales order table. Likewise, I have another method called ingest US cells, and it is inserting a copy command into US sales order table, and then another method which is called ingest FR cells, and it is copying the data from internal stage location to FR cells order. One important point, each of these select statement also having a sequence number, which is again not supported by copy to table Snowpark API. Maybe it will be supported in future, but right now it is not supported. Here I am also converting the necessary data type as and when applicable, and finally I am invoking this 3 method from my main method. Before we run this Snowpark program, we have to create this sequence object, and we also have to create these tables. So the table script is also available in the same file. So let's switch to the source schema. This is my first table, which is going to hold the data from CSV file format. And if you look into this, it has a sales order key, which is an incremental value. Then I have one-to-one mapping with my CSV file, and then I have some metadata information which will come from your staged file, and we will show how it is going to be useful. Likewise, my next table is US sales order, which is going to capture the US sales data which is available in a Parquet format. And this also has one-to-one mapping with Parquet data file, and it has sales order key, which is an auto-generated key, which will come from the sequence object, and these are also having the metadata file. And finally, we have table for France, which is called France sales order. It also has auto-generated key followed by one-to-one mapping with JSON data type and metadata. So before we ingest data, let's create this file format. And again, you can find the script from my blog page. So I have given the name called India sales order sequence, US sales order sequence, and France sales order sequence. And they are all created under my source schema. Good. So I have France, India, and US sequence orders, total 3 items. Now I am going to create India sales order table. Now this sequence objects will be associated with your sales order key when we run the copy command, and that we are going to cover in our Snowpark program. So before that, let me create these tables. So I can see I have France, India, and US sales order available under my source schema, and they are all transient table type. It is recommended not to use a permanent table unless otherwise you really need a permanent table. Again, if you have not understood the difference between permanent, transient, and temporary table, I would request you to watch objects available in Snowflake and their associated costs through this video. This is my stage 2 source Snowpark Python code. It has 4 different methods which are being invoked from the main method. The first will get the session object, and other 3 will help to load the data from stage location to the source table. This is, I am calling this ingest India cells, ingest US cells, and ingest France cells. And here I am also executing the count before and after copying the data, and it will show the count. Let's see how this ingest India cells looks like. If you see, I am just running a copy command into the target table, and I am giving a sequence object here, which is my India cells sequence. And I can make sure that I have this object available. And here also I am giving very specific location because I don't want to have the object privilege issues. So this is reading the data from the source location from India folder and copying it. Make sure that on error you put the continue. Similarly, I'm just giving this data warehouse source. This is also copying from all source equals to US, Parquet, and this is having a fully qualified path, looks good. And finally, I have this source France and this source France, looks good. So let me run this program and let's see what does it bring. Before I run, let's go and check whether my table shows any copy history or not. So when I come to my Object Explorer, I click on France cells and I do not have any copy history. Likewise, India does not have any copy history, and US also does not have any copy history. All the data set is 0. This table is created 7 minutes ago. Okay. So my India sales order count is 0, and let's see what data it brings after the data is copied. So it has got close to 1.4 million rows. So it has 862K records for US, and we have 682K records for France. Okay, there are a small mistake here which I will correct it. Now let's refresh this and see whether data is copied and reflected in this copy history tab or not. Yes, I can see the total 1240 files are loaded in US. Here 1241, 1.4 million rows. And here I have 682K records and 1241 records loaded. So all the data got loaded and I haven't seen any rejection. So using this simple Snowpark API, I managed to copy all the data at no time. Since I have written 3 different methods, however, if you have a lot of commonalities, you can write all 3 methods in a single method and still generate the same outcome, and it will make your entire long SQL script in a much more concise and more manageable code base. Now let's run the select statement and see how the first 10 records looks like. Now you see it is a much more faster. The important thing between the stage location versus the location where I have the data available in the table format, that I have this metadata file name, which is nothing but exact partition file name, and this is the row number, which particular row from the file is actually represented by this row in the table, and what is the last modified date time available in that file timestamp. Let's see how the US data looks like. So in the US, it is all snappy Parquet, and if I go for France, this is all your JSON and it is primarily a JSON file. So we successfully managed to load thousands of files from our local machine to Snowflake internal stage, and by running the Snowpark File API as well as Snowpark SQL API, we are able to move data from internal stage to the table including the metadata column. So in the next step, we are going to use Snowpark Data Frame API to move the data from source table to the curated table and also perform some basic transformation operation. If you come to the query history screen, you would notice that everything what Snowpark does is nothing but a SQL statement. So here it is actually running a copy statement using the sequence object followed by $sign. Okay, and this is my Snowpark driver, and it took 11 seconds, 12 seconds, and 10 seconds to load millions of records. One important thing, in case if your Snowpark program fails for any syntax error, it is a little hard to debug because it does not convert that incorrect SQL into a proper SQL, and that SQL is not registered with your Snowflake. And that is the one of the challenge I have noticed with Snowpark API. And you will get a message like this without any additional help. Now our next step, which is one of the important steps in this entire flow, is to move data from source schema to curated schema. This is also one-to-one mapping where US cells data will move to US cells curated data, India cells data will move to India cells curated data, and France cells data move to France cells curated data. You may have a question, when we have a one-to-one mapping, why are we not moving the data directly from source location to the consumption zone? In real life, source location may have a variety of column name and they will not conform to our business naming convention. So to ensure that we have a easy to maintain ETL program, generally the data is moved from source location to the curated location, where first data is cleaned, curated and deduplicated before it is further made available to the modeled layer, and that is the primary purpose. In our example, most of our fields are having the same name, and that's why you will find it little odd or extra burden. However, in real life, you need to have a curated layer before you move your data to the consumption layer. So let's see how our Snowpark program looks like, because in this layer, we are going to use some basic transformation. With that, you would understand how to use Data Frame API. Before I go to my VS Code, here is example code available in my blog page. I have written 3 different Python files where each of the data source is being processed. When I say each of the data source, it is India, US and France. This particular Python file again establish a connection, apply some filter, and in the main program we are actually performing some join operations to bringing a proper naming convention and finally saving the data. Okay, let me jump to my VS Code. So this is my 06 source to curated India Snowpark program. This particular Snowpark program is loading your India order dataset. These are my import function, this is my logging, and I am getting the connection from my get Snowpark session function. Here I have a common filter method which will take a data frame, column name, and apply the filter criteria. So first I am selecting all the data from India sales order table, and to make sure that I am very clear, I will write the fully qualified path. So I am taking the data from the source layer and then calling the filter dataset, where I am trying to consider only the paid payment status and where shipping is delivered, and these two filter statement will be translated in SQL form like this. Now since I am processing India dataset, I am going to add one column called country and region. India belongs to APAC, Asia Pacific region, so I am going to use with column function and adding country as India and region as APAC. You will find a pretty much similarities between PySpark and Snowpark. Here I am using these functions which is available in your Snowpark functions library. Moving next, I am actually fetching exchange rate data as a Forex data frame, and then I am creating another data frame by joining the country sales DF, join Forex DF, and here I am giving on the order date. So it will perform a join operation between exchange rate table and your India sales table, and it will do the outer join. It means if it does not find any record in the exchange rate table, it will consider as a null. Okay. However, the data is pretty much validated, so you would not find any empty record. And here you can specify the join type, which can be inner, outer, anti, and there are a few more options. Okay. Now it is possible that we may have a duplicate record. And how do I know the duplicate record if I have the same order data being processed twice? For that, what we are going to do, we are actually adding a column called order rank, and order rank is primarily ordering all the same order using this metadata last modified date. Whichever file has come later will get the lower rank, and whichever file has come early, which will get a higher rank, and only the higher rank will get the priority. So if you have a duplicate orders, whichever order rank first will be selected based on this criteria. And once it is selected, I am going to use this sales order key, which is my sequence number generated through the sequence object. Once I get this unique orders after removing the duplication, I am going to join this unique order with my sales order, which has a duplicate, and finally getting a cleaned order dataset, which has order date, order ID, order date, and it has a country and region, and it has a local currency, local unit price, promotion code, local total order, and I'm also performing some operation where I'm converting the local values into the USD using this formula, so including the shipping address. Okay, so now this mobile number is converted into the contact number. So you can see I have used different alias to rename the column, and once I get this my curated clean deduplicate data, I am going to call a function called write.save as a table. If the table doesn't exist, the table will be created. If the table exists, it will append the data into the table. This is how this Snowpark Python program will curate, deduplicate, add necessary column to your dataset, and finally load the data into your Snowflake table. So before I execute this Snowpark data frame program, I would like to create my sequence object and tables in my curated layer. You can find the script in my blog page. Jumping to Snowsight. They are pretty much repeated stuff, but they are being created under a different schema. Now I am going to run this create or replace table called in order. And if you look, they have order values in US as well as they have order values in local currency. And how do you know what is a local currency? By looking at the country name. Similarly for US, country and region, and here it has a USD value. Its USD value and the local value would be same because exchange rate between USD and US is same. Going to France, it has a local currency as well as USD order values. Let me create these three tables. So they are created successfully. Three tables are created under curated schema. Okay, looks good. If I run this SQLs, it will have empty tables. Yes, I do not have it. So since my tables are created successfully in my curated layer, now I am going to run India sales order curated Python program. Let me execute this and see what happens. This time I have enabled the log, so it is actually printing all the SQL statement, and it says that query executed successfully, and finally the message is appeared that insert into curated India sales order. Let's go back to Snowsight and see how does it look like. Let's run this curated in sales India order table. You see, this is my sales order key, which is a surrogate key, followed by order ID, order date, and this is a customer name. And I have added two additional columns called country and region, and order quantity. and local currency is INR, and this is your local price, and this is my local total price, and this is my exchange rate. This is the rate in US dollar, this is the tax amount in US dollar, and I have only the delivered item and the paid item. Okay, now let's go and check how my table looks like from the Object Explorer menu. So I will go to my curated layer, I will click on a table. I can see I have a 3 sequence numbers, and I have so far populated only India sales order. And here I have a 227K record because out of 1.4 million rows, only the paid and the delivered items are selected, and there is no duplicate item available. And data preview, this is how it looks like. And if I click on the copy history, the copy history is blank through the Snowpark data frame API via insert statement and not through the copy command. If I go to the query activity, I can see this is my insert statement. So all your complex transformation which you have performed through your data frame API is converted into a single SQL statement, and then you manage to insert the data writing few line of code. Otherwise you would have end up spending a very complex query. For a US and France, I have created another files called 07 and 08. The only changes I have done it here is that it is reading the data from US sales order, and here it is reading data from France sales order, and finally applying the same logic and inserting data back to the France sales order table and US order sales table. Let me run this to Snowpark program and load the data from source to curated location. So data got inserted into US sales table. Next, running the 8th program which will populate France data. It also got executed pretty fast and France data is loaded. Let's go back to Snowsight and check it. Let me refresh the query history first. So France data is inserted. I have US data also inserted. Let me run the US sales order from the curated table. So I have this auto-generated key, and then I have a US and North America as a region. This is my local price, and this is my US price. They are all same. Looks good. And this is a contact number and shipping address. Looks good. Here I have France data from Europe and this local currency. So this also looks good. So France got 170K record, and US got 143K record, and India got 227K record. Looks good. So my curated data got loaded successfully, and now I have a completely clean deduplicated data available along with my local price and US price, followed by country name and region name. So in the next step, we are going to combine all these 3 tables and going to create a modeled layer. So I assume you have been following me so far, able to download your data from my Git location, arrange the data in a partition format, moving the data from your local machine to the internal stage, from internal stage running the Snowpark program to move the data from internal stage to source table, from the source table running the Snowpark program to move the data to the curated layer after applying some basic filtration and curation logic. Now this is the last stage where we are moving the data from curated to consumption zone and also going to populate the fact and dimension table. We are not going to elaborate and explain what is a fact and dimension table, and I assume you have a good knowledge what is a fact and what is a dimension table. From the single sales order dataset, we are going to create total 7 tables. This is your star schema, or we can call it fact and dimension table. If you look into the order sales data, which looks like this, here we have some common data set. For example, mobile data set, which is nothing but a product data set. Other side, we have a country and a region, which is just 3 entries. Then we have a promotion code for each country and each region. So that is also a very small data set. We also have the payment method per country, per region, and then we have the customer information. All those master data set will be first extracted using a distinct query on the order table, and once we extract those master table, we are going to create this dimension table, and each of the dimension table will have auto generated key which is called underscore id underscore pk. So for example, for customer it will be customer underscore id underscore pk. For a date it will have a date underscore id underscore pk, and so on. And then we will create a referential integrity between this dimension table with a fact table and keep only the measure available in this table. So if you look into this fact table, it will have a order id pk, order code, date id fk, region id fk, customer id fk, payment id fk, product id fk, promo code id fk, and followed by all the measures like order quantity, local total, order amount in local currency, tax amount in local currency, exchange rate, US total, order amount in US, and tax amount in USD. Okay, so this is our final transformation where we are merging US, India, and France dataset and converting that dataset into this total 7 fact and dimension tables. Before we run our Python code, we would like to create sequence object as well as structure of our dimension table as per our requirement. This is a very simple representation. In real world, this fact table may have a slowly changing dimension type 1, type 2, type 3, or type 4. And we will also make sure that we create the constraint. Once these table structures and relationships are created, we are going to run this Snowpark code, which will actually populate the data to different dimension and fact table. I'm back to my consumption schema. Let me switch my schema to consumption. And I'm going to create a region dimension under my consumption schema. And before that, I'm going to create a sequence object. And if you look into this dimension table, it is having a pk followed by country and the region and is active flag. If you look into this table, this is my country, this is my region. Many of the dataset in this order table is specific to country and region. So let me create this table. So it is created. Next, I am going to run the product dimension table, which has mobile key, brand, model, color, and memory. So first I'm going to create a product dimension sequence object. And if you look into this mobile key, it has a brand, model, color, and the memory specification. Okay, and that's what we are going to capture here. The third dimension table is a promo code, which is specific to country and specific to region. So my sequence object is created, and if I come to this promo code looking same here. However, they may have a different number and different applicability based on the country and a region. So let me create this. So I will have a country and region. Next, I will have a customer dimension, and my customer dimension will have a customer name, contact number, shipping address, country, region, and is active. Okay. And so my customer dimension is also created. Next is my payment dimension. I may have a different payment provider and payment method, and they are also specific to country and region. Then finally, I have the date dimension. So my date dimension starts with date ID pk, order date, order year, day counter, order month, order quarter, order day of week, order day name, day of month, and weekday. So my dimension tables are created. Now I am going to create a fact table which has most of the foreign key referential integrity available. Snowflake allows us to create a constraint. However, it does not enforce the constraint. So you have to make sure that you maintain the integrity programmatically via soft rule. However, there is no hard rule applied in Snowflake. So let me create this fact table. So my fact table is successfully created. Now I am going to create a couple of constraints with those fact table along with the 6 dimension table. So under the consumption schema, I can see total 7 table, 1, 2, 3, 4, 5, 6 dimension table, 1 fact table, and for each of the table, I have a sequence ID, which is nothing but a Snowflake generated ID. Good. Now we will try to understand how our Snowpark program looks like. This is a long program because everything is done in a single program by having a multiple methods. You may have to go through this part of the video twice and thrice to understand what's being written and actually what is happening under the hood. So let's jump to our VS Code. So this is the file called 09 curated to model Snowpark Python program. If you look into the line number 214, which is getting a session object, once it gets the session object, this line number 216, 217 and 218 is nothing but getting 3 different data frames by running the select statement on the curated table. Now once it gets the data from all these 3 tables, it primarily run a union operation to union all those 3 data frames into a single data frame. Now I have got a single data frame. On those data, based on this data frame, which belongs to different country, different region and different currency applicability, I am going to create a dimension table. And if you look, first I am going to create a region dimension, followed by product dimension, promo code dimension, customer dimension, payment dimension and date dimension. Okay, we'll quickly go through them one by one. This method can take care history as well as delta load. Now, once this data is written into the dimension table, we are going to get the primary key and the necessary parameter for comparison and again get date dimension data frame, customer dimension data frame, payment dimension data frame, product, promo code and region. And once we get them, we apply a join function with my sales data and finally store the sales data along with all foreign key. So this is the logic at very high level and this is how we do in our data warehouse world. Now let's quickly go through this dimension method and try to understand what they are doing. So first we are going to create a region dimension. So here we are running a group by query on the country and the region and attaching is active key. Once we get the record, we try to join the data set with existing region dimension table if using the left anti-join, and if the data already exists, it removes the data from the data frame and finally save the data into the region dimension. So this is how we populate the region dimension. Next, when it comes to the product dimension, we primarily split the product into the mobile product into brand, model, color and memory along with the mobile key, and then we run the group by query the way we have done it for a region and we check whether this product already exists in my product dimension. If yes, exclude them. If not, please go and insert the data into the product dimension table, right? If you go to the promo code, it follows exactly the same approach where we are doing the group by country and a region. Okay, we are also making sure wherever the promo code is null, we are attaching not applicable, else our calculation will go wrong. And once it is done, we do the join using left anti and ensure that the data, if already exists, should not be inserted. If the data is not available, then it has to insert into the promo code dimension table. Good. And this is line number 111 where we are saving the data. We follow the similar approach for a customer dimension where group by is performed on a country, region, customer name and contact number followed by shipping address. Okay, and we are checking whether this customer exists or not. If the customer does not exist, then it will be part of the customer DF, else it will be excluded, and finally saving the data into the customer dimension table. Next, we are moving to payment dimension where the payment method and the payment providers are captured. Here, for each country, each region, we are trying to check payment method and payment provider and check if the payment provider is already available in the dimension table. Yes, then exclude. If not, be part of the data frame. Finally, save the data into payment dimension table. The date dimension is slightly tricky, and here we have applied a different logic. Here we are using a pandas data frame to make sure that we generate all the dimension data and finally inserting into Snowflake. So we generally try to take the start date and end date, and for that date range we generate different kind of date dimension attribute, which includes your year, day counter, month, quarter, and everything, including the weekdays, whether it is a off day or it is a working day. And then finally follow the same approach. If that date dimension entry exists into the dimension table, exclude it. Otherwise, you create a data frame and save the data frame into the date dimension table. You can pause and you can understand what code is written. You can also refer the blog page for entire code snippet. Now let me run this Snowpark program and let's see how does it bring the result. So my curated to model Snowpark program started, and you see the data is being populated. So all the 6 dimension table got populated, and finally it is inserting data into sales fact table, and that also completed successfully. Let's go back to Snowsight and quickly check how it looks like. So I have 352k customers available. If I look into the date dimension, I have 1.2k, which looks exactly same because I have 1240 records are there starting from 2020. And if I go to the payment, the data looks like this. I have 52 different payment methods and provider under different country and different region. And if you look into the product data, this is how the product data looks like: brand, model, color, and memory. If I go to the promo code, I have different promo code available under different country and region. If I go to the region, it should be only 3. And when I go to the fact table, this is how the fact table looks like. So I have total 730k. So my entire data set is populated successfully with one single program. And if I go to the query activity, so here you can see so many statements are executed, which is nothing but insert into different table and finally insert into. So these are all my statement which is executed through your Snowpark. Now I have connected with my Snowflake instance with my consumption layer, and I can see the entire dimension table available in this form. Okay, good. In the next step, we are going to use Snowsight to draw the sales KPI dashboards. So this is my fact table, and I have other 6 dimension table where all the data is successfully populated. So what would I do? Now I will go to my dashboard, try to create a couple of filters and add the different tiles within my dashboard. So let me create few filters. So I'm able to fetch the data. Let's add this filter. Now my dashboard is ready, where you can see the total sales in USD, the revenue by country. So this is India followed by US followed by France, month-wise revenue in USD, and this is my daily sales order and my daily sales quantity. If I change this number from 2020 to 21 and say apply, so now I see a very different number. If I choose 2022 and click on run, so this is how my end-to-end ETL is working, and I can create this very simple vanilla dashboard for my business team with filter. If I want, I can also apply additional filter and use those filter in my query. Now we have drawn the dashboard. Let's try to process a delta data and see what changes we have to make in our Snowpark program to make sure that it processes only the delta files. So here I populated data from 2019 for roughly 1 quarter. So I have data set available from 2019, and same thing is applicable for US as well as France. So now I'm going to push this data through my entire ETL process and see how this data reflects to our dashboard. So I have additional delta CSV file from 2019 in JSON format, CSV format, and Parquet format, and they are available inside this location under the sales folder. Now let's move that data using this Python. We had already executed this program, and I'm going to rerun this. Since I have only the delta data available in my local machine, it will only copy those roughly 90 multiplied by 3 into my stage location. So let's check how many data set we have it in this location. So I have 3.7k records. Good. Now let's run the program. So I am going to fast forward as this may take a while. So when we initially loaded the data into our internal stage, this was the count we had it, and it was close to 3700 files. Now let's run this command first and see how many new files have been loaded to our internal stage. So it is 3987. Good. If I run these individual SQL files, so 1329, this is also 1330, and you see here I have 2019 dataset available. Let's try for US. This is also 1328. So we can see roughly 300, close to 300 new files from 2019 last quarter has been added to the system. Now let's go and see how we can rerun our Snowpark ETL process to quickly load the data and what changes we have to make in our code so only the delta data file is processed and not the entire file is reprocessed. So next we are going to run file number 05, which says stage to source, where we are going to move the delta data from stage location to source table. And since it is running a copy command, the copy command will maintain the history and it will not reload the data which already exists in our stage location. So let's run this program and also see what is the record count before and after the copy command. So we have the old count 1.4 million, and now after the data is being copied, the number has increased. Also for US, the number has increased, and for the France, again number has increased. So the copy command is running perfectly and it is only copying the delta file. Looks good. Now when we are coming to the source to curated file, there will be one change which is required to make sure that the data which already exists in the curated location should not be reloaded. For that, we have to select all the order ID from our curated location and make a left anti-join to make sure that the order which already exists excluded from our new select. Okay, so I have added this two line in each of this file 06, 07 and 08, which are responsible to load India, US and France data. Let me run this Snowpark program quickly. and first check what is the record count looks into this table. So this is the record count in my existing curated table. After I run my delta processing, the number should increase to a new number. Let's go back and check how the number looks like. So now I can see the delta data has been processed successfully. Now we are in our final Snowpark file which says curated to model. There is only one change which we need to apply to make sure that we only process the delta record. We fetch the data from sales order from India, US and France, and we create a union. Once this union is created, we actually fetch the data from our sales fact consumption table by taking the order ID, and we apply the left anti-join to make sure that the orders which are already processed should not be processed again. Rest of the operations are exactly same. There is no change on that. And if we just run this file, it will automatically process the delta file. Okay. So let's go back to our Snowsight and check how much data we have it in our sales fact table. So we have 713K records. Let's run our Snowpark program and process the delta data to this layer. So my execution is completed. Let's go back and check. Now I see I have 788K records. When I execute select star from date dim, I can see I have 2019 data available. Looks good. Let's go back to our dashboard and quickly refresh. Now here I have 2019 data also available. Let me click on that. And the number is much more smaller compared to the rest of the numbers because it is just a Q4 data for all the countries. Okay, so this is how you can use your Snowpark APIs to process your data starting from your local machine till end of your consumption layer. We can create variety of dashboard using our Snowsight dashboard feature. And let's see one additional dashboard after we have repopulated the delta data. So in this dashboard, I am using two filters where first filter is fiscal year and second filter is a country filter. And I can choose year 2021 and I can choose the country India and I can say run. And here I can see sales quantity by brand, year, country, where year and country is coming from this filter, and you can see how this data is distributed across different brand. On the other side, if you see sales amount by mobile memory, and it looks like we have to do the data curation appropriately because 4 space GB versus 4 GB needs to be combined together, okay, because they are the same data set. This is sales amount by payment method and here sales amount by payment provider, and you can check the different payment provider here. If I change the country from India to US, let's see how does it change. So I have Master, PayPal, Samsung Pay and American Express. So this is how my data changes based on this filter, and you really don't need any other tool to visualize your data set as a plain vanilla dashboard. So considering the Amazon's mobile data setup and global sales order data, we have practiced how to load the mobile order data set from local machine to Snowflake internal stage, how to create file formats for commonly used file types, run the copy command to load data from internal stage to source schema, validate the copy history and behavior of delta processing with copy command. We also used Snowpark File API to load the data from local machine to Snowflake internal stage. We used Snowpark data frame APIs to curate the data to bring uniformity as well as delta load when we loaded 2019 sales data. And finally, we created fact and dimension table in our consumption layer using Snowpark Data Frame API. And then we also created Sales KPI dashboard using Snowsight dashboard and filter capabilities. All of them free of cost using Snowflake free trial edition. If you have made it this far in this comprehensive hands-on guide, I am confident that you have learned a lot. I would sincerely like to express my gratitude for sticking with me and listening so patiently. The solution or the approach provided here is not something best, and this could have been done in many ways, or I would say much more efficient way. There are a lot of ways to solve the same problem where data can be ingested and processed, and this use case or approach can be enhanced or revalidated with following points which are not covered in this hands-on guide. Delta processing can take advantage of Snowflake stream objects. Snowpark code can have more reusability. Sequence objects can be replaced by using auto-incremental in DDL. Exception handling can make the solution more robust and resilient. Having a better naming convention patterns. Having audit table in audit schema to check and monitor the data processing. Thank you again for watching this entire Snowpark end-to-end ETL hands-on guide. If you have learned something valuable from this content, don't forget to press on the like button and share with other data engineers and Snowflake developers. Happy learning and keep growing.